In the vast tropical plantations of Southeast Asia, a massive industrial operation begins at the crack of dawn.
Old oil palm trees that have stopped producing fruit are pushed over to make room for replanting.
Chainsaw operators quickly slice the fibrous trunks into standard log sections before the organic material begins to degrade.
Hydraulic excavators load the heavy, water-saturated logs onto rugged cargo trucks for immediate transport to the mill. A continuous convoy of transport vehicles navigates the rough plantation roads to deliver 10,000 trees daily.
Upon arrival at the processing facility, each truck is weighed to document the daily intake of raw biomass.
The raw logs are dumped onto the concrete sorting yard, waiting to be fed into the production line. Front-end loaders push the cylindrical logs onto a heavy-duty chain conveyor that leads directly into the factory. The logs pass through a rotary debarking machine, which strips away the rough outer skin and spiky fronds.
Laser scanners measure the diameter of each clean log to calculate the optimal cutting pattern for yield.
A vertical bandsaw slices the round log into square cants, revealing the pale, fibrous interior grain.
These square blocks are immediately pushed through a gang saw, slicing them into multiple thin, uniform slats.
Workers manually inspect and sort the fresh slats, discarding any pieces with excessive rot or structural defects. At this stage, the palm wood is extremely porous and contains water levels exceeding 200%.
Automated stackers arrange the slats onto pallets with spacers to allow airflow to reach every single surface.
Forklifts transport the stacked timber into massive kiln drying chambers to begin the critical moisture reduction process. The chamber doors are sealed shut, and the temperature is gradually raised to evaporate the internal water. Technicians monitor the drying schedule for weeks, ensuring the wood does not crack or warp under heat. Once the moisture content drops below 10%, the pallets are removed and allowed to cool down.
The dried wood enters a high-pressure vacuum vessel where it will undergo a chemical resin impregnation process.
A specialized polymer resin floods the chamber, penetrating deep into the soft vascular bundles of the palm.
Extreme pressure forces the strengthening agent into the fibers, transforming the soft material into a hard composite. The treated slats are removed from the vessel, now significantly heavier and denser than the original raw timber. A secondary heating phase cures the resin, locking the polymer structure permanently inside the organic wood fibers.
The cured slats are fed into a high-speed planer machine to smooth the rough surfaces and equalize thickness.
Scanning reveals the unique, exotic grain pattern that distinguishes palm wood from traditional oak or maple lumber.
Rollers apply a strong industrial adhesive to the edges of the slats in preparation for block lamination.
Hydraulic clamps press multiple slats together to form large, solid panels suitable for manufacturing wide furniture pieces.
After the glue sets, these laminated panels possess the strength and stability required for high-end carpentry applications. Wide belt sanders calibrate the panels to a precise thickness, removing any glue residue from the lamination process.
The prepared material is transferred to the cutting department, where the fabrication of luxury furniture components begins.
Computer numerical control machines carve complex geometric shapes and joinery details with sub-millimeter level cutting accuracy. The automated system switches tools instantly to drill holes, route edges, and carve patterns without human intervention. Powerful extraction systems remove the fine dust immediately. Operators carefully remove the machined components, checking the measurements against the digital blueprints to ensure total compliance. Cylindrical table legs are shaped on high-speed lathes, turning the square stock into elegant, rounded forms.
Sharp chisels shave away the material, revealing the striking black and gold flecks inherent in palm grain.
Multi-head boring machines drill precise holes for dowels and screws that will hold the furniture assembly together.
Technicians perform a dry fit of the components to verify that every joint aligns perfectly before gluing. High-strength wood glue is injected into the joinery holes, and wooden dowels. The assembled frame is placed into a pneumatic press, which squares the joints while the adhesive cures. Assembly workers diligently wipe away any excess glue from the joints to prevent staining issues later on.
Complex curves that machines cannot reach are sanded by hand to ensure a smooth, tactile surface finish.
Orbital sanders with fine grit paper prepare the wood surface for the upcoming staining and lacquering application stages.
Compressed air is used to blast away microscopic dust particles that could ruin the final clear coat finish.
The clean furniture pieces are suspended on an overhead conveyor line that transports them into the spray booth.
Robotic arms apply an even coat of stain, enhancing the natural contrast of the palm wood fibers.
The stain penetrates the surface, darkening the dense fibers while leaving the softer tissues a lighter shade.
Ultraviolet lamps cure the stain instantly as the pieces pass through the drying tunnel on the conveyor.
Workers perform a light scuff sanding between coats to promote adhesion for the final protective lacquer layers.
A durable, high-gloss polyurethane lacquer is sprayed over the piece to seal the wood against moisture damage.
Inspectors examine the wet finish under bright lights to detect any runs, drips, or trapped dust particles. In the upholstery department, artisans cut premium leather hides to fit the seats of chairs and sofas.
Industrial sewing machines stitch the leather sections together with heavy-duty thread to ensure long-lasting seam durability.
High-density foam is cut to shape and glued onto the wooden seat frames to provide ergonomic comfort.
The leather cover is stretched tight over the foam and secured to the frame using pneumatic staplers.
Excess material is trimmed away from the underside, and a dust cover is attached to hide internal components. The finished upholstered seat unit is bolted securely to the lacquered palm wood base using reinforced metal screws.
Protective felt pads are applied to the bottom of the legs to prevent scratching of customer flooring.
A final cleaning removes any fingerprints or smudges before the furniture piece is approved for the packaging line.
A laser engraves the company logo onto a small metal badge that signifies the authenticity of the product.
The badge is tapped gently into a pre-routed recess, sitting flush with the surface of the finished wood.
Packers wrap the furniture in layers of protective foam sheeting to cushion it against impact during global transit. Reinforced cardboard corner protectors are placed inside the box to provide additional structural rigidity to the packaging. The wrapped chair is lowered carefully into the heavy-duty cardboard carton, fitting snugly to prevent internal shifting. Automated taping machines seal the top and bottom of the carton, securing the contents for international shipping logistics.
Shipping labels containing destination data and handling instructions are affixed to the side of every single carton.
The boxes are stacked onto wooden pallets and wrapped in plastic film to create a stable shipping unit. Forklifts load the pallets into 40-foot shipping containers, filling the volume efficiently to maximize transport value per mile. The loaded containers are hauled by truck to the nearest seaport, beginning their journey to markets worldwide.
These products cross oceans, bringing sustainable luxury material from tropical plantations to urban homes in distant continents.
At the distribution hub, the shipments are broken down and sorted for delivery to individual retailers and customers. Staff members unpack the furniture in a luxury showroom, arranging it to highlight the unique palm texture. The distinctive grain, resembling a leopard print, sets this material apart from traditional hardwoods like oak or mahogany. Customers appreciate the smooth finish and the heavy, solid feel that results from the specialized densification process. Entire bedroom suites can be constructed from this material, utilizing the thousands of logs processed every single day. Beyond furniture, the processed palm timber is also used for decorative wall paneling and architectural interior elements.
The hardened density makes it an excellent choice for flooring, capable of withstanding heavy foot traffic and wear.
Back at the factory, waste material like bark and sawdust is not discarded, but redirected for energy.
The biomass waste is fed into on-site boilers to generate the steam and heat required for the kilns. This self-sustaining energy loop reduces the carbon footprint of the manufacturing process and lowers operational electricity costs.
Research laboratory continuously tests samples to ensure the impregnation process meets strict international structural durability standards.
Microscopic analysis confirms that the resin has completely filled the vascular bundles, preventing water absorption and rot. Design teams constantly explore new forms and applications to maximize the aesthetic potential of this sustainable timber. Digital modeling allows engineers to simulate load-bearing capabilities before a single piece of wood is ever cut. Prototypes are hand-built and rigorously tested for comfort and stability before mass production templates are finally approved. This industrial ecosystem converts what was once agricultural waste into a high-value commodity for the global market. In the fields, young saplings are planted to replace the old trees, restarting the 25-year growth cycle.
The sustainability of this industry relies on the continuous management of the plantation resources and responsible harvesting.